For people working in terrestrial systems, it could be fairly easy to go out and count the number of moose on a, or deer on a pasture, let's say. For marine or aquatic systems, you actually have to put, we don't live in those systems, right? We're literally fish out of the water. So we have to get into those systems and collect those data via other tools. My name is Michelle Gaither, and I study eDNA and evolution in fishes. eDNA is short for environmental DNA, and it basically is the DNA that all of us shed continuously. Fishes that swim through the water also shed cells, they shed mucus. When they reproduce, they shed gametes into the water column. When they die, they shed, their bodies and their decomposing bodies shed DNA. And that DNA that's found in the water is what we call environmental DNA. First thing you need to understand in order to conserve a resource is what that resource is, where it exists, and when it lives in that or exists in that place. So that's just the baseline data for any kind of conservation efforts, and environmental DNA helps us to get at that. Environmental DNA has as a tool, has the ability to help us understand better how communities change, which species live where, and when, and how that will change through time. Marine or any kind of aquatic realm, it's much harder to get a sense of who lives where when. I mean, if you're just on your boat, you don't know who's below. And so eDNA is one survey tool that can help us answer those questions in a much more efficient and hopefully a much more complete manner.